Hi, welcome to this course by RouteFabric. During today's session, we will be going over the topic of data science. We'll be addressing this at a very high level. I'll start with just an overview of what data science is, why it's important, and some uses of data science and different types of analysis that are conducted as a part of the data science process. And then I'll conclude with a couple of drawbacks or cautions related to data science and building machine learning models. So what is data science? It's a very popular term these days, and it can be defined in a lot of different ways. In fact, if you Google data science trying to find a definition, you'll find a whole host of different ideas, different ways of describing what data science is. A lot of the definitions of data science, you'll notice, have Venn diagram-like overlaps, where really it's demonstrated that data science is a intersection of quite a few fields and quite a few ways of thinking about the world and thinking about problems. And rather than give a very particular and potentially limiting definition of data science, we are going to define it quite generically as the practice of collecting and understanding and analyzing and then drawing conclusions from the many, many sources of data that are available in our modern world. Now, to go about doing these analyses and drawing conclusions and figuring out how to understand different patterns and different data sets that are available, we will use a variety of disciplines, a variety of methodologies, and that is where all of the myriad definitions come from, is different people with different backgrounds approach data science in different ways. But really at its core, data science is very focused on the data and on collecting that data, organizing and understanding that data, and then analyzing the data in order to solve some problem or to draw conclusions and aid businesses or societies or governments in making decisions and being efficient. Now, there are a lot of pieces of data. I'm sure this is not news to most of you. If you've been awake for the past 20 years or so, data is everywhere. And in our digital world, we have more data than really we know what to do with. I've collected a few interesting statistics related to data here on this slide, trying to demonstrate the magnitude of how much data is out there, how much data is being generated on really a daily basis. There is a lot of data, which is good for data scientists like me, because everything that we do requires data, and the more data, the better in many ways. Data, if it gets too large and too messy, too noisy, then it can be hard to find anything or to draw any conclusions. But on average, the more information that we can collect about a given problem, the better our predictions will be, and the more we'll understand, the more we can account for different things in a given prediction scenario. So as you read through some of these bullet points, hopefully you'll agree with me that data is large and it's growing, and it's not slowing down anytime soon. Now, there are various kinds of analysis that we perform as a part of the process of data science. And I'm going to talk about three different kinds. The first is what we call descriptive analysis. And you can think of descriptive analysis as describing something that happened in the past. So if you have a set of data and you look at that data and try to answer questions about what that data tells you, then really you're describing, or you're using the data to describe a situation. So for example, if we look at sales that occurred by region of some country, or maybe region of the world, that's us looking at the amount, or maybe the average, or a number of ways we could measure sales, and dividing those sales into different regions so that we might compare regions and understand what happened maybe last year as we were selling product throughout the world. Another example would be conversion rate by product category. Again, looking at a specific piece of information that describes what happened in the past. In this case, looking at how many people purchased items in different product categories out of the total amount of people who maybe visited your website or who were marketed to in some way. That's another example of a descriptive analysis. Average shipping rates over time. Again, if we're looking at maybe the past 5 years and trying to understand how shipping rates have changed worldwide, or for a given company, or for a given supplier, we are again describing what has happened, and we're summarizing information about what has happened in the past. That's an example of descriptive analysis. Final example, life expectancy by country. Life expectancy is a measure of things that have happened in the past, and that we could summarize perhaps by country, and describe different measures of life expectancy, and maybe compare different countries. All of those are examples of descriptive analysis. One can usually identify descriptive analysis by charts. Often descriptive analyses are best represented in either tables or charts of some kind. Bar chart is kind of the classic example of a descriptive analysis, showing different values divided across a set of categories. A second type of analysis is something that we might call diagnostic analysis, which goes beyond descriptive analysis to help us understand not only what happened in the past, but to try to get some answers as to why something happened in the past. So I've listed these 4 examples that we started with on the last slide here. And in each case, as opposed to just describing sales by region in a descriptive analysis, a diagnostic analysis might actually help us understand what features of those different regions, maybe median household income, average age of the demographic population, various other features that could influence or maybe explains why sales are higher or lower in these different regions. Likewise, for conversion, again, how many people purchased an item in different product categories, a diagnostic analysis might help us understand what aspects of those categories, maybe the average selling price, how comparable products are with each other, or maybe how customized a product has to be to a given individual's personal preferences. I'm thinking, for example, of a book versus a shirt. When someone purchases a book online, they know what they're getting. Typically, it's just a book with pages and words that they can read. Whereas a shirt, even if you buy the right size of shirt, different shirts have different textures and different fits, and that's one aspect that might influence conversion. It's really easy as an online shopper to go and purchase a book and have it shipped to you and know that you're getting what you want, whereas conversion rates for shirts or other items of clothing might be quite a bit different. These are examples of diagnostic analyses, ways that we are describing why different product categories might have different conversion rates. Average shipping rates over time. What maybe explain those different shipping rates by other related pieces of information that help us understand things that influence shipping rates. I'm thinking of an oil price index, or maybe trends over time as manufacturing centers move to different countries or to different regions within a country. As those change over time, shipping rates might be affected. And that's an example of us diagnosing why shipping rates are tending to change over time. Lastly, life expectancy. Just describing life expectancy by country is useful, but it's much more useful to understand what are the underlying factors in those countries, maybe access to clean, potable water within different countries, or maybe healthcare spending per capita. Other things like that might help us to diagnose or to explain why we are observing differences in life expectancy across different countries. So that's a good summary of diagnostic analysis as compared to descriptive analysis. The last type of analysis that I'm going to talk about today is called predictive analysis. This is really the exciting part of data science, and this is where we get to use the information at hand to make predictions about what is likely to happen in the future. So again, staying with these 4 categories, rather than just describing or maybe diagnosing why things have happened in the past, predictive analyses would give us the chance to make a guess, hopefully an educated, a good guess about different aspects of these different analyses. So in the sales by region example, if we adjust the product mix, for example, to match demographic variables in each region, and we try to achieve a product mix and demographic fit, we could build a model or do a predictive analysis that might indicate that would produce a certain percentage increase in sales in different regions. For conversion rate, maybe if we removed a few clicks or a few steps in an online checkout process, we might be able to predict a certain percentage increase in conversion rates. Maybe those increases might be influenced by product categories, and maybe there's 2 or 3 categories where removing 3 clicks might produce even higher increase in conversion rates. Those are the kinds of predictions that one might make when doing predictive analyses. Average shipping rates over time, if we can use and understand how that oil price index, for example, influences shipping rates, then we might be able to establish a relationship where if the oil price index goes down by 2%, we could expect a 1.8% decrease in shipping rates. And maybe there's a time lag in that decrease. A predictive analysis might allow us to make those kinds of predictions, which would be really useful to a given company. Maybe your company ships things all over the world, and if you watch oil price indexes, then you could have a 4-month lead time on understanding whether your shipping is going to be higher or lower, and that might make you more informed as you do supply chain planning, for example. Lastly, again, rather than just describing or sort of understanding why something has happened in the past, if we can understand and make predictions about life expectancy, given the things that influence life expectancy, then a predictive analysis in this case would perhaps indicate that if we have additional government subsidized healthcare spending of some sort, maybe increasing it by 10% will have a direct effect on life expectancy. These are hypothetical examples, of course, but it's an example of what a predictive model, predictive analysis might allow us to guess and make informed guesses. So this predictive analysis is, again, it's kind of the exciting part of data science, and it's what most people think of when they think of data science and companies engage in analytics. Typically, they're trying to understand, given the data that they have available to them, they're trying to make better decisions about what's going to happen in the future to help them be more profitable, to help them lower expenses, to increase sales, all of those types of things. Now, I mentioned data science is a very popular word these days. It's kind of a buzzword, actually. And I'd like to talk for a moment about why that is. So we live in a time right now where data science has kind of found its prime. And what I mean by that is we have at least 3 things that have kind of come together that make data science a very compelling endeavor, and they make it possible for companies to invest in data science and really start to get some return on their investment. And there's at least 3 factors that I might label as reasons for why this is happening now and why it's such an exciting time to be learning about data science. For one, as we talked about, there's a ton of data. As our world has digitized everything from shopping to temperature and demographic information, to weather patterns, to anything that you can think of, really, with our Internet of Things and with sensors being placed on everything, we have just piles and piles of data. We've talked about the fact that there are large data sets available to us. But when you pair massive data sets with both algorithms, so powerful analysis techniques, as well as accessible technology via, in most cases, cloud-based analysis infrastructure, when you pair all of those 3 things together, you get a really data science friendly environment. And that has allowed companies and organizations and academic institutions to make significant advancements in our ability to understand data and to make predictions from data. And it's made for a very exciting time for we who are in the industry and who are interested in data science and in helping businesses and individuals and other institutions derive value from this data. I'm going to close with just a brief word of caution about data science. We can get really excited about the things that we can predict and the accuracy of certain models and the efficiencies that we can provide for companies, but we do need to be aware of some of the potential drawbacks. Algorithms, which we'll talk about in other sessions, algorithms are really just ways that humans have taught computers how to think and how to find patterns in data. Because algorithms are formulated by humans, and humans are in many ways inherently biased, and sometimes those algorithms can exhibit the same biases. We like to think of computers as rather impartial, but when humans are doing the teaching and we're the ones designing systems for computers to learn within, then sometimes our biases can come out in our algorithms, and that can have harmful effects. In addition, as data science continues to advance, in many ways, our algorithms have become black boxes. What I mean by that is, rather than a simple statistical relationship like a simple linear regression, where we understand that an increase of one or more independent variables will correspond to an increase in some dependent variable. That's pretty basic math and something that we all learn in our low-level math classes. But our algorithms and our methods are much more complex in our modern data science world, and these black boxes sometimes suffer from a lack of explainability. They make it hard for us to understand why the model is predicting certain ways, and they can make it hard to validate the results that they can be trusted and that businesses can use them for decision making. There's ways to help and get around some of those difficulties, but it is an issue as algorithms continue to be more complex, then they lose their explainability. And there's some who argue that that's okay, that as long as it works, then it works, and there's some value to that. But it is, there's a lot of people who struggle with just trusting a model that was built through a data science process, that and trying to understand whether that's something that they can trust is still kind of out for debate. 2 other examples of sort of this dark side of data science: self-fulfilling prophecies. If this is completely hypothetical, but let's say that we built a model that predicted that people who were 50 or older were much more likely to commit crimes. I'm sure that's not true, but let's assume that our model said that, and that we, within our state government, we decided to trust that model, and we started having our law enforcement target 50 and older individuals because they're more likely to be committing crimes. What that would do is it would create a lot of arrests and a lot of punishment for those who are being targeted, for those 50 and older people who are now considered suspects almost just because of their age. What that does is the statistics would continue to support that relationship, because the only people being caught would be those who are 50 and older. And in that way, a model fulfills its own prophecy and continues to reinforce itself, and the police department might for decades continue to trust that those older individuals really are the problem people in society, and that can be a problem because we don't always understand, or we don't always make accurate prophecies with our models. On the other side, we often have a lack of what we might call a feedback loop. For example, one might consider performance in school to be associated with higher test scores. And while that may or may not be true, many admissions decisions are made based on assumptions like that. And if we just only ever let people who are in maybe the top 20% on a certain standardized test, those are the only people that we let into the university, then we don't really understand whether the bottom 80% would have done well, and whether our model is really very accurate. We exclude from consideration that bottom 80%, and that creates a situation where the model continues to assume those people don't exist, or that they don't need to be predicted about, and we don't feed other information back into our predictions to help our models improve over time. So data science is a wonderful discipline, and it's exciting, and there's lots of very interesting job opportunities and career advancement opportunities. I don't want to focus too much on the dark side of data science, but I'd want you to think a little bit about data science. And those of us in the data science field who try to be socially responsible, we try to keep those things in mind as we build and think about models. Thank you for listening and participating in today's session. For more information, you can check out our other courses on RouteFabric.com. Thanks for watching.